Okay, can everyone see this?
Yeah.
So I looked up documentation about how to do profiling, and this is what is built into Pharo. As far as I can tell, this is the main profiler, but the visualization is not that great because you pretty much only have tree views or raw text. There's a profiling visualization called flame graphs, which you may or may not have heard of. You can Google it very easily, but they look like this. Basically, it's a way of visualizing the call stack. So the bottom is the original function, and then the rectangles that you see on top of each function are the things that are called. So you can see do it calls run, calls A calls B and C, B calls D and E, and the widths indicate how long is spent in each function. The idea is this is a really high dimensional way of showing you where your time is spent, and it gets around some of the problems with other profiling dumps. Because you know sometimes if you look at just the leaf functions in the profiling report, you'll get caught on something like integer add or something. But this makes it easy to just ignore the top layer if it's a bunch of irrelevant leaf functions. I'll do a quick demo of there's a demo of the UI libraries. It takes a minute to run. So the demo builds this gigantic grid, and it has a few hundred rows in it and takes a couple seconds to come up. And I was interested in where the time goes in that. So if you look at the profile, then you can see it calls open on the window, and then it's building the contents. And then up here, you can see it splits into 3 columns. First name morph, second name morph, age morph, and that's where it's, I closed it. That's where it's assembling the 3 columns of widgets. I guess actually there's a 4th column, and I'm not sure where that went in the profile. I guess it's taking up less time. It's this narrow column here. So profiling visualization is interesting to me. If anyone else is interested, I would be interested in talking about it. Was that clear? Are there any questions?
I like that actually. It's, and the shading, is that like the red shading? Is that like the
colors are random currently. This is not my invention. The original flame graphs used random colors so that you can tell apart small rectangles that are close together. Otherwise, they can kind of blend together.
One of the things I noticed when I was doing the connectors demo in my videos was that the more connectors you added and then did the complete graph to them, the slower things got as far as clicking, because it had to go through the whole hierarchy to figure out where something was. And it would slow down. Once you add about 100 nodes and all of the connections between those nodes, and you tried to click on something, it would take a very long time before Morphic would actually pop up and show where you had clicked. And I'm just curious, as when I drilled through it, the mouse click went through dozens of levels of hierarchy before it actually came to the level where something actually showed on the screen. And this doesn't look complicated enough to be showing that. It looks like it's missing large numbers of levels of the hierarchy that a single mouse click goes through if you have a complicated layer of collection of morphs on the screen.
I'm just profiling the construction of this window. I haven't tried. That would be a great thing to profile, definitely, especially if you're talking about, laggy UI is not something that you want, and it would be great.
Well, you just create 100 morphs and connect every single one of them with a line, which is also a morph. Mm-hmm. And then you click on it and wait.
Okay, that's a great test case. I'll have to try that out.
I like the fact that your flame graph looks like a flame.
I can't take
if-
credit. That is traditional.
Are we looking at, like, for instance, one of the bottom lines there says open followed by build contents. Is that one method invocation of build contents? And if build contents was called many times, is there any way to summarize all of the calls to all of the build contents rather than seeing each one graphed out vertically?
So one important thing about flame graphs is that they're not chronological and they're not tracing. It does not keep track of every single call to things. It only takes samples. And so
Okay.
what you're seeing here is just open maybe called build contents once, maybe it called it 1,000 times, but it spent about 95% of its time in build contents one way or another.
Right.
I wonder if that could be,
sorry,
could
that's
have a third dimension added to show the number of times it's called, you know, layers of calls.
Yeah, that can be difficult because usually flame graphs and the profiler, you know, the existing profiler is a sampling one, so you can't, you tend to miss stuff. You don't necessarily know exactly how many times something was called.
Right.
If you are interested in that kind of information, you want to do tracing, and that's a kind of a whole different technique, and you might want a different visualization for that. As usual,
cool,
different visualizations are better for, they're more suitable for different problems.
is there any way to find out what some of those really thin boxes are?
The next thing to add that these kind of visualizers usually have, like I said, if you do a web search for this, lots of people do these, and there are interactive ones online, so you can see what it looks like in like a, you know, a server running on Unix or something like that, and you can see where system calls go. So usually you can click on any rectangle and it'll zoom that to be the full screen. And then you'll, you know, so if I clicked on age morph here, then that would take up the full width of the screen and everything would get proportionally wider.
Okay, so you could effectively zoom in on everything.
I think I broke it a little bit, but you know, it does resize pretty well, and information, you know, it just shows as much as it can given the space available.
All right. Sorry.